Welcome to episode 19 of our hashtag SaaS Startup series, where we delve into cutting-edge cloud computing architectures. Today, we'll explore two vital components shaping modern cloud infrastructure: serverless architecture and the role of DevOps in continuous integration and continuous deployment, cicd. These technologies are transforming how businesses build, deploy, and manage applications, enabling faster innovation, scalability, and cost efficiency. So, if you're ready to unlock the future of cloud computing, stay tuned. Understanding cloud computing architectures. Cloud computing has redefined how organizations manage and deploy applications. Rather than relying on traditional on-premises infrastructure, businesses are moving towards cloud-based architectures that offer flexibility, scalability, and cost-effectiveness. But what exactly does cloud computing architecture entail? At its core, cloud computing architecture consists of the components and subcomponents required for cloud service delivery. This includes the front-end platform, client or device, back-end platform, servers and storage, a cloud-based delivery model, and a network infrastructure. These components work together to deliver services such as computing power, storage, databases, and networking over the cloud. Cloud architectures are classified into several models, including 1. Infrastructure as a Service, IaaS, provides virtualized computing resources over the Internet, including servers, storage, and networking. 2. Platform as a Service, PaaS, offers a platform allowing customers to develop, run, and manage applications without dealing with underlying infrastructure. 3. Software as a Service, SaaS, delivers software applications over the Internet, often on a subscription basis. Now that we've laid the foundation, let's dive into serverless architecture and how it's revolutionizing cloud computing. Serverless architecture. A game-changer in cloud computing. Serverless architecture has emerged as one of the most innovative cloud computing models in recent years. It enables developers to build and run applications without managing servers. While the term serverless may suggest the absence of servers, that's not the case. Instead, it means that the cloud provider handles the server management, freeing developers from the complexity of maintaining infrastructure. How does serverless architecture work? In a serverless architecture, developers write functions that respond to events or requests. These functions are then deployed on cloud platforms like AWS Lambda, Azure Functions, or Google Cloud Functions. When an event triggers the function, the cloud provider automatically allocates the necessary resources, runs the function, and then scales down once the task is complete. This on-demand scaling is one of the key advantages of serverless architecture. You only pay for the compute time your code consumes, making it highly cost-efficient. Unlike traditional cloud models where servers are running 24/7, serverless ensures you only use resources when needed. Advantages of serverless architecture. 1. Reduced operational overhead. By outsourcing server management to the cloud provider, organizations can focus on coding and innovation rather than infrastructure maintenance. 2. Scalability. Serverless platforms automatically scale based on the number of requests, handling sudden traffic spikes seamlessly. 3. Cost efficiency. With serverless, you only pay for what you use, avoiding costs associated with idle servers. 4. Faster time to market. Developers can deploy new features quickly without worrying about provisioning servers or managing infrastructure. Use cases for serverless architecture. Serverless architecture is ideal for scenarios that require rapid scaling or event-driven processes. Some common use cases include: 1. Web and mobile backends. Serverless is perfect for handling dynamic content, user authentication, and real-time data processing in web and mobile applications. 2. API gateways. Serverless functions can power APIs that scale automatically to meet demand. 3. Data processing. Serverless is well suited for real-time data processing tasks, such as IoT data streams or log analysis. 4. Chatbots and virtual assistants. Serverless architecture can support natural language processing and other tasks that require low latency responses. Challenges and considerations. While serverless architecture offers numerous benefits, it's important to consider some challenges. 1. Cold start latency. Serverless functions may experience a slight delay during the initial invocation, known as cold start latency. 1. This can impact performance in latency-sensitive applications. 2. Complex debugging. Debugging serverless functions can be more complex than traditional applications due to the distributed nature of the architecture. 3. Vendor lock-in. Relying heavily on a specific cloud provider's serverless platform can make it difficult to migrate to another provider in the future. Despite these challenges, serverless architecture continues to gain popularity, especially as cloud providers enhance their offerings to address common concerns. DevOps and continuous integration, continuous deployment, CI/CD, accelerating software delivery in the fast-paced world of software development, speed and agility are crucial. This is where DevOps and cicd come into play. DevOps is a cultural and operational approach that integrates development and operations teams to improve collaboration, automate workflows, and deliver software faster. cicd, a core practice of DevOps, involves continuously integrating code changes, testing them, and deploying them automatically. What is DevOps? DevOps is more than just a set of tools or processes. It's a philosophy that aims to break down the silos between development and operations teams. Traditionally, developers would write code and then hand it off to operations for deployment and maintenance. This often led to bottlenecks and slower release cycles. DevOps bridges this gap by fostering a culture of collaboration, where development and operations work together throughout the software lifecycle. The key principles of DevOps include: 1. Collaboration. Developers and operations work together to share responsibilities for building, deploying, and monitoring applications. 2. Automation. Automating repetitive tasks like code integration, testing, and deployment allows teams to focus on innovation and problem-solving. 3. Continuous improvement. DevOps encourages continuous feedback and iterative improvements, ensuring that software quality is always evolving. The role of cicd in DevOps, continuous integration, and continuous deployment, CD, are practices that automate the process of integrating code changes, testing them, and deploying the application to production. Continuous integration, in C, developers regularly merge their code changes into a shared repository. Automated tests are run to ensure that new changes don't break the existing codebase. This frequent integration reduces the chances of conflicts and allows teams to identify bugs early. Continuous deployment, CD takes automation a step further by automatically deploying tested code to production. This eliminates the need for manual deployments and ensures that new features, updates, or bug fixes reach users faster. cicd pipelines are typically implemented using tools like Jenkins, GitLab CI, Circle CI, and Ozcode pipeline. Benefits of DevOps and cicd. 1. Faster release cycles. With automated testing and deployment, teams can deliver software updates more frequently and with greater confidence. 2. Improved collaboration. DevOps fosters a culture of shared responsibility and communication, leading to fewer misunderstandings and smoother workflows. 3. Higher quality software. cicd pipelines catch bugs early, ensuring that only thoroughly tested code is deployed to production. 4. Reduced downtime. Automated deployment and monitoring allow for quick rollbacks or fixes, minimizing downtime and improving reliability. 5. Scalability. DevOps practices enable organizations to scale their development and operations processes efficiently as they grow. Best practices for implementing DevOps and cicd. 1. Automate everything. From testing to deployment, automation is at the heart of DevOps. 1. Use automation tools to handle repetitive tasks, allowing your team to focus on coding and innovation. 2. Implement continuous monitoring. After deployment, use monitoring tools to track the performance and health of your applications. 2. Continuous monitoring ensures that any issues are detected and resolved quickly. 3. Foster a collaborative culture. Encourage open communication between development and operations teams. 3. Regular meetings, shared responsibilities, and a focus on common goals can help build a strong DevOps culture. 4. Start small and scale gradually. Begin with a small project to implement DevOps practices and scale them across your organization as you gain experience and confidence. Integrating serverless architecture with DevOps and cicd. Serverless architecture and DevOps, CI/CD are not mutually exclusive. In fact, they complement each other. By integrating these two approaches, organizations can achieve greater agility, scalability, and efficiency in their software development and deployment processes. How serverless enhances DevOps. 1. Faster deployments. Serverless functions can be deployed instantly without provisioning infrastructure, making it easier to implement continuous deployment pipelines. 2. Improved scalability. Serverless platforms automatically scale based on demand, allowing DevOps teams to focus on application logic rather than infrastructure scaling. 3. Cost efficiency. Since serverless platforms charge based on usage, integrating serverless with cicd ensures that you're only paying for resources when they're actively being used. cicd for serverless applications. Building cicd pipelines for serverless applications requires a slightly different approach compared to traditional applications. Here are some best practices. 1. Automate testing for serverless functions. Create automated tests to validate serverless functions before deploying them. 1. These tests should cover both unit testing and integration testing. 2. Use infrastructure as code, IAC. Tools like AWS CloudFormation, Terraform, and serverless framework enable you to define your serverless infrastructure as code. 2. This makes it easier to automate deployments and maintain consistency across environments. 3. Implement monitoring and logging. Since serverless functions are distributed and event-driven, continuous monitoring and logging are essential for identifying and resolving issues in real time. By combining serverless architecture with DevOps and cicd, organizations can accelerate their development processes while maintaining high levels of scalability, reliability, and cost efficiency. Conclusion. Embracing the future of cloud computing architectures are continually evolving, and staying ahead requires adopting innovative technologies like serverless architecture and embracing DevOps practices like cicd. By leveraging these approaches, businesses can achieve faster time to market, improved scalability, and greater agility in their operations. As we wrap up episode 19 of our #SaaS Startup series, remember that the cloud is not just a platform for running applications. It's a dynamic ecosystem that can drive your business forward. Whether you're just beginning your cloud journey or looking to optimize your existing infrastructure, embracing serverless architecture and DevOps can be a game changer. If you found this content valuable, don't forget to like, subscribe, and turn on notifications so you won't miss the next episode. Thank you for watching, and stay tuned for more insights into the world of cloud computing.